Hello guys, this is D Sai Sampath from Team Bias. Now I am here to explain basic forensic tools like Binwak and JudgeTech. What is Binwak and where do we use it? Let's go through Bias Wiki to get a clear idea of what Binwak is. Binwak is a tool used for searching embedded files and executable code within another data file. What does it mean? For example, someone had embedded an image file inside another image file. It need not be an image file, it can be a zip file or a text file or an audio file, any data file which is embedded inside the other data file. To extract them, we can use the tool binwak. Now let's see the installation procedure of this tool and let's see the uses. And for getting a clear idea on how this tool works, let's solve a challenge. You can install this tool using the command sudo apt install binwak. In my system, it's already installed, but if it's not there in your system, it will be done. Now let's go through the usage. Binwak -e and then the name of the file. It extracts all the embedded files in this particular data file. In this image, you can see binwak deeper.jpg. Deeper.jpg is the data file in which the files are being embedded. Here you can see that there are total 4 data files which had been embedded in this. Now let's see how to extract them. Here I have a challenge, Con-The-Cat from Topoda. Here the description says that this image seems to be a big for a normal PNG. Seems to be big for a normal PNG. What do you think can be hidden in this? Here they are saying that the size of the PNG had been increased. Do you think the size of the PNG will increase normally? No, it won't. Someone had embedded some other file in this PNG such that the size of this PNG has been increased. So let's see. I had already downloaded this challenge file. You can use the command binwak and then the name of the file to view what all the files had been embedded in this. Here we have total 6 and the first 0 says that it's just this PNG, such.png, and the next one refers to zlib, and the next 4 are the JPEGs which are been embedded in this such.png. Now let's extract all 4 of them and let's see what is in it. You can extract them using the command either binwak -a and then the name of the file, or you can use this dd carving tool to extract all of them and then the name of the file. This will create a folder. In the folder, you can find all the extracted data files. Here, there are total 6 files. These 6 files represent these 6 files. Here, 0 represents this PNG and this 1W, 1E represents this JPG and 15E7D represents this JPG and 1E8D represents this JPG. These are named by their offset names. That's it. So you can either open them using the Chrome or you can open them just in your normal image viewer just by changing the extension. You can change the extension using the command mv and then the name of the file .jpg. Now let's view these files and let's see what's in it. See, I got the flag in CTO. You can't see me. Now let's solve a challenge in JudgeTech. Before that, let's get a clear idea on what JudgeTech is. To get a clear idea, let's go through BIOS Wiki once. What is JudgeTech? JetStack is a tool like JStack, but it is used to detect LSB steganography only in the case of PNG and BMP. JetStack won't work for all the data files. It will work only for the PNG and BMP. JStack is a tool which works for JPEGs. Here in this tool, it will detect the LSB steganography. What is LSB? LSB means least bit steganography. For example, let's consider an image. Let's consider this is an image, and let's consider this as a 2D plane. All our images are 2D plane images, right? So let's see. In this image, every value corresponding to a particular x and y coordinates. Using this x and y coordinates, we can extract pixel. What is pixel? Picture is made up of huge number of pixels. If consider this is a picture, and every part of this is corresponding to the pixels, and each pixel is made up of RGB values. What are these RGB values? These are nothing but these helps in creating a color, and each value varies from 0 to 255. When you are converting 255 in binary, it is 2 power 8 minus 1. So totally R corresponding to the 8 bits, and G is corresponding to 8 bits, and B is corresponding to 8 bits. In these 8 bits, how can you see them? Let's consider a random 8 bit 0, 0, 1, 1, 0, 0, 1, 1. Here, the last one is corresponding to the least significant bit, and the first one corresponding to the most significant bit. What is difference between most significant bit and least significant bit? When you are changing the LSB, when you are viewing the picture, it won't show much difference. But when you are changing this MSB, the picture you are viewing can change to any other format. Why? Because this most significant bit plays a crucial role in representing the pixel. In this manner, for each pixel, there are three values RGB. In steganography, when you are hiding the data in it, you can either hide only in R, or only in Z, or only in B, or you can hide them in all these three of them. Remember that you should never change MSB. You should always hide your data only in LSB. Uh, Now let me show you a program. How do we extract this pixel and what do we do it? In this program, I imported PL library and I loaded an JPG named pixel.jpg. I will show the JPG. This is just a normal JPG I took for the explanation part. Here I am loading this pixel.jpg in IM, and then using these coordinates I am accessing the pixels. Initially I told you, right, every pixel is having a corresponding coordinate value. If you are changing the coordinate value, you can access the pixel. Using the dot get pixel, you can get the pixel values. Let me run this command. See, I am printing the pixel values. Here it's 75 to 12, 20. If I am changing the coordinates, the pixel value will change. Now let's see the uses of this JetStack tool in the installation part. And for getting a clear idea, let's solve a challenge. You can install this tool using the two commands sudo apt install and then sudo gem install. Now let's solve a challenge. I'm taking a challenge from Troboda. The challenge name is LSB-PNG. The most significant bit is not always left unnoticed. I had already downloaded the source file. Let's see. You can run the tool JetStack just by using the command JetStack, and then the name of the file, scooby.png. Here it is extracting all the data hidden in this image. Here when you see that b1 comma rgb comma lsb comma xy, here this data is being stored in the rgb value in the lsb. If this data is stored in the msb, you can see b1 comma rgb comma msb. Initially I told you when I am explaining this part, you can either store in only r or only z or only b. Here if you are storing the data in only r, it will be in this format, b2 comma r comma msb comma xy. Here the author had hidden the data in rgb values, so it's b1 comma rgb comma lsb. If you need some other help regarding this tool, you can use the command jetstack --help. Thanks for watching the video.